Hello, everybody. My name is Dr. Jay Kumar. Currently, I'm working in Dalhousie University. Have been doing postdoc as well as right now. Currently, I'm working with CUS as a CUS Atlantic organization as a artificial intelligence developer. So today, I'm going to discuss the work I have been doing for the past couple of years related to the ocean data. So the title definitely gives you a brief intent that I'm working on an AI integration in ocean data. So let's going into the next thing that specifically what's a ocean and what's a role of ocean in economy. So maritime transport is actually the backbone of global trade. So almost 80% of the global trade is conducted through the medium of ocean. That's why the high number of vessels, and their system needs to work on to do the business anyway. Almost 50% of the fishing activities in the ocean actually provides 15% almost of the protein in the food chain. Additionally, with the business and the fishing activity, it also has been a medium of passenger transportation from island to island from country to country. So in conclusion, it's a very basic part. So the challenge is that there are heterogeneous amount of data which has been generated from different sources. So how AI can be most important tool because right now AI is at every sector, and how AI can actually facilitate, or the researchers can leverage this tool from and extract some pattern from the existing data. So I'm going to discuss two problems today which I have been working on for past couple of years, since it has been I have been working with the vessel data as well as the ocean properties data. So I'm going to discuss both in a sequence wise. So first, I'm going to discuss about monitoring vessel movements. Vessels are specifically we call as a ships. So ships in the oceans, which are different. There are variety of types of ships anyway. So the next thing is that what ocean variables like biodiversity, ocean data specifically, what's the broader properties, what's the biodiversity, what kind of things are there in the ocean. So these data has been collected from different sources. I'm going to talk about that how AI is actually facilitating or providing a basic component to expedite the things, to expedite the processes anyway. So let's talk about the first, monitoring vessel movement, what kind of challenges I have been working on. What's the ocean traffic transportation system? Actually, basically, what is it that if a vessel moves, a vessel or ship, we can call it as a vessel or ship, whatever you need to call. So it has a receiver, and it has a receiver and a transporter. So the thing is that whenever the vessels are moving towards the ocean, they actually throw a broadcast signal. So that signal is definitely encrypted, and that signal, as you can see on the right hand side, there's an image that a vessel is actually transported or broadcasting a signal which is caught by the satellites, or it depends what kind of a thing is, like either they are caught by the satellites or the local stations. So stations have their antenna as well as the satellite. So the messages which are received by the satellites are called AIS messages, and the messages which are received by the local stations, which local stations specifically, which we can say that coast guard stations anyway. So these are called, the message type is called VMS messages. So specifically, VMS messages are broadcast or received by, like, broadcast by fishing vessels, because fishing vessels are very near to the shore. So it's like 40 to 50 miles away from the shore. That's why the nearest coast guard or receiver stations can receive these kind of messages from the fishing vessels or fishing ships. However, when a vessel moved like towards the other, towards the open sea, definitely there are satellites which are receiving the messages, and these messages are again transferred to the particular data warehouse or data storing stations. So that's how the things goes on, and it this system actually regulates very real time. So you can, there are several websites you can track the vessel's movements anyway. So this data collected over the time, over the like past 2 decades, has actually encountered researchers to make it more easier or conveying, or the make a more route safer and short and optimize the cost anyway in business. So what I was targeting in the past few couple of years, when this was my first project in here related to the ocean vessel data, that there is a specific type of whales which are at the edge of an extinction. So Canada is supporting a particular project which are how the movements in the vessel, like movements on this ocean, or what kind of studies can make, can actually prevent this extinction of this right Atlantic type of whale. So they are called like Atlantic right whales, North Atlantic right whales. So specifically, there were two things which was causing actually the death of whales. First, that vessels or ships move very fast through a particular route. So they then on that route, so the chances are very high. And the next thing is that fishing gear entanglement. The fishing, whenever the fishing happens with the fishing ships, what they do actually, they anchor the fishing gear, which is called the fishing net. So sometimes the whales are entangled and they are actually more injured because of that net, sharp net. So that causes the death of the whale. So these two specifically type of threats were found when there was a study going on. So my task was to analyze the movements of the vessel over this North Atlantic right ocean region. So there are different types of messages, red and yellow and green types of messages. We won't be going into any of these, but anyways, the right hand side, it shows the density map. It's a route map of June 2017. The on the there are red circles with the highlighting the yellow area. So these are the areas where there is an abundance, where there is the existence of the North Atlantic right whale. So my study was to actually predict that how vessels are moving and what will be their next 12 hours trajectory. A trajectory is a path or a steps. So my target is to analyze the current 3 hours trajectory of a vessels and predict that what will be the next 12 hours trajectory. It is actually very challenging because in the ocean we don't know that what, where, and like where are the vessel moving and how usually for some ports definitely there are some assigned path, but it's very hectic for the Coast Guard to manage the traffic because the information in the AIS messages related to the position and the name and characteristics are very are very confident, but we cannot confident over the destination of the vessels or ship to moving towards a particular port. So that was a challenging anyway. So this kind of a model. So with the team, with personally, we trained the model based on a transformer and with feature engineering, and we training the different layers of the model. This is the basic transformer model. On the left hand side you can see there are obvious input, actual, and predicted. So input path is very short, and you can see the predicted one and the actual one are very much aligned together. Perhaps the predicted one is more ahead of the actual one, but somehow it actually follows the same path. So the next topic I'm going to discuss is data management of ocean variables with the biodiversity. So for the past 6 months I have been working with the CUS Atlantic. It's a Regional Association of Canadian Integrated Ocean Observatory, like observation system. So what they do, they have they the sole purpose of CUS Atlantic is to provide open source data, open source libraries for researchers, organizations, for the institutes, so that they can actually get benefit from this one. And this definitely is funded by the government. And what that whole team do is actually communicate with the collaborators or contributors, find their way to collect the data, manage the data, and to make the users, to end users, to harvest the data wherever they want. So this is the sole purpose of Atlantic, like CUS Atlantic organization. If you go to the CUS Atlantic .ca, I'll give you the link anyway. So this is kind of a demonstration of their Explorer. So the dots, green and dark green and like light green, shows where the different kind of data has been collected. So let me give you a little bit background what kind of data is collected through in this region, because different type of researchers, scientists have been doing and collecting like doing research and collecting data from different types, different regions of ocean, like what is the density, what is the salt, amount of salt in the water, what's the waves, what are the current flows, what kind of animals are found, because there is a different whole set of science on the every level of the ocean. So like geologists are working on, and biogeologists as working on, biochemistry is also working on. There are different type of things and different types of data is collected from the satellites as well as buoys. Buoys are called a particular kind of robots, you can say that, which goes into the ocean and collect the data and send the data to the satellites or store the data. So buoys are particular kind of these kind of robots, you can say that. They sometimes do charge by themselves, or they sometimes need like external charging anyway. So this is kind of a demonstration that how a user can actually explore the different kind of regions and different type of data. I'll just explain in a brief way that what's the data management pipeline. So like in the first step, we have different contributors. We can have contributors, means who actually sends the data. So they might be coming from satellites, like weather satellites or different types of satellites anyway, and they may come from the buoy. So on the in the yellow icon, it's called a buoy. What they do, actually they send us a data with the metadata. Metadata is about the data, what kind of characteristics, what is the attributes, what is the fields, what type of data, what their ranges are, what their significance, what's the information, from where it is collected, what is the region. So such kind of a data about the metadata. And that goes into the data pre-processing, where different things has been checked, that what are the validations, like if there's an outliers are there, what is the format we need, what kind of, so transformation, cutting like outliers, and validation or data quality checking. So these all things has been are done in the data processing step. So next thing is that prepared data is then published on the online portal to get the for the user. So user can actually interact with the published data and harvest, download whatever region, whatever fields they want. So my work has been involving to integrate AI in data processing and publishing step. In terms of data processing and publishing, what I was doing is to establish a data set recommendation system. Like if you have visited any kind of online shopping e-commerce website like Amazon, like eBay, so these kind of, whenever you traverse an item, right, it actually recommends you a similar kind of item. So there is a bunch of we have hundreds and thousands of data sets coming from hundreds of the ocean fields. So whenever different kind of researchers or different kind of users, either a student from a different fields, comes and integrate with our systems, they need to search right now with the terms and then search the data. So our idea is to implement a recommendation system, which is basically what it is going to do is it's going to find the similar group of data sets with the similar properties. So the integration and grouping and linking the data set with each other can actually produce a data set recommendation system. So that's how our team, or specifically we are working, our organization is working on towards the best benefit of the users. And the whole team is funded by the funders government, and everything is open source. Thank you so much for listening me, and I really apologize for not being on a real time. I really appreciate it, and hope all the best. So these are the few references for the where I have taken some images, as well as the explore.cs, the image which I show how the data can be explored. So it's on the fourth link, explore.cs. Thank you so much. Again, my name is Dr. Jay Kumar, Dalhousie University, CS Atlantic. Thank you so much.